ISO IEC 1024 accredited certification body committed to helping individuals and organizations stay future-ready in a rapidly evolving world. GSDC is accredited by the Accreditation Board for International Certification Bodies, ABICB. For 10 years, we've certified more than 100,000 professionals across Europe, North America, Asia, and Africa, with our offices in Switzerland, the United States, and Singapore. Our programs are recognized by leading publications and podcasts, including Forbes, Tech Target, People Managing People. We offer 100-plus globally accredited certifications across emerging and in-demand domains like Generative AI and Emerging Technologies, HR and Learning and Development, Project Management and Agile Scrum, ISO and Quality Management, Information Security. Each GSDC certification is designed to empower professionals with confidence and help organizations stay competitive in a fast-changing landscape. Every certification is crafted with insights from 100-plus global advisory board members representing top universities and leading industry experts. Our certified professionals are trusted by 500-plus multinational companies, which help unlock better roles, faster promotions, and delivering cutting-edge expertise. We partner with 100-plus authorized training partners and 50-plus universities, supporting talent across all career levels, from entry-level to executive leadership. As a GSDC member, you gain lifelong access to interactive webinars, hands-on workshops, SME panels, and global summits. Join a vibrant community of 25,000-plus members and be part of our global events. Check our reviews on Trustpilot. We're trusted worldwide for quality, support, and impact. Whether you're aiming higher or building tomorrow's talent, GSDC is your partner in purposeful growth and impactful leadership. Visit our website to explore our offerings. GSDC, share the best practices and learn from the best practices. Welcome to the Global Skill Development Council, your gateway to digital transformation. We are an independent, vendor-neutral ISO IEC 1024 accredited certification body committed to helping individuals and organizations stay future-ready in a rapidly evolving world. GSDC is accredited by the Accreditation Board for International Certification Bodies, ABICB. For 10 years, we've certified more than 100,000 professionals across Europe, North America, Asia, and Africa, with our offices in Switzerland, the United States, and Singapore. Our programs are recognized by leading publications and podcasts, including Forbes, Tech Target, People Managing People. We offer 100-plus globally accredited certifications across emerging and in-demand domains like Generative AI and Emerging Technologies, HR and Learning and Development, Project Management and Agile Scrum, ISO and Quality Management, Information Security. Each GSDC certification is designed to empower professionals with confidence and help organizations stay competitive in a fast-changing landscape. Every certification is crafted with insights from 100-plus global advisory board members representing top universities and leading industry experts. Our certified professionals are trusted by 500-plus multinational companies, which help unlock better roles, faster promotions, and delivering cutting-edge expertise. We partner with 100-plus authorized training partners and 50-plus universities, supporting talent across all career levels, from entry-level to executive leadership. As a GSDC member, you gain lifelong access to interactive webinars, hands-on workshops, SME panels, and global summits. Join a vibrant community of 25,000-plus members and be part of our global events. Check our reviews on Trustpilot. We're trusted worldwide for quality, support, and impact. Whether you're aiming higher or building tomorrow's talent, GSDC is your partner in purposeful growth and impactful leadership. Visit our website to explore our offerings. GSDC, share the best practices and learn from the best practices.
Hello, everyone. We'll be starting this session now. Please allow me to share my screen. Here we go. I hope my screen is visible to you all. And thank you so much for joining today's session. And I give you all a warm welcome to Global Skill Development Council, GSDC Certified Learning, Driving Efficiency and Innovation in Manufacturing with Generative AI, with a theme that is Drive Smart Production and Operational Efficiency with AI Solution. My name is Preetham. I'm going to be a host for this session. If you need any assistance during the session, you can reach out to the chat box and I'll take care of it. And I'm really excited to host this entire webinar series, which is scheduled from 13th October 2025 with a time slot that is 8:30 a.m. Central, 9:30 p.m. Singapore time. We've already done with one session yesterday, and today we'll be having the another session. So please do join us for all our remaining sessions for this series with the same time slot. And today we'll be having Jayant Reddy Rodla with us, and he'll be taking us through the topic that is predictive maintenance and process optimization with AI. So before he could start with his session, I would love to take a moment and introduce our hosting organization, GSDC. We're known as Global Skill Development Council. We are vendor agnostic, vendor neutral, and we are globally recognized certification body. We are accredited by NSI and APICP, and we have more than 100 plus certification portfolio with us. And we have certified more than 250,000 professional worldwide. We have 500 SMEs. Those are subject matter expert, industry experts. They work with us closely to design our deliverables. Also, there are affiliates from top universities like Harvard, Stanford, MIT. And also, we are associated with 1,000 multinational corporates and 500 Fortune companies and 50 plus universities across the globe. And it's very proud to inform you all that we do have 100 plus authorized training partner across the globe. We have partner in Asia, Africa, Canada, America, and many other countries. So whoever joined us through our training partner channel, thank you so much. In case if you're looking for any training program for yourself, I'll be sharing the link in the chat box of our training partners. Feel free to reach out to them for to have the inquiry regarding the training program that if you are looking for any. A special thanks to our official media partner, World Press Hub. They cover all our events and press releases. As I mentioned earlier in my previous slide, we do have 100 plus certification portfolio. So our current certification portfolio holds certification on emerging technologies, agile DevOps, quality and compliance, learning and development, digital transformation, and so on. So in case if you're looking for any of this certification in order to upskill yourself, you can definitely reach out to our learning advisor or you can visit the below website, which is www.gsdcouncil.org to check more information and to check all the offerings that GSDC has for all of you. So, what benefits you will be getting if you opt out a certification from GSDC? You will become a GSDC's member for a lifelong. With that, you'll be getting certificate upgrade and you'll be having free access to all our events, workshop, boot camps, and guess what? You will be having free access for all our exclusive learning program that we have. With that, you'll be getting implementation resources, speaker invites, and newsletter. Isn't it great? So do check out our website and do sign up yourself for certification programs. So without any further delay, I would love to tell more about Jayant. So Jayant is advanced manufacturing engineer at Aztec Industries, where he leads corporate initiatives in AI-driven process optimization, predictive maintenance, and Industry 4.0 integration. With over a decade of experience across automotive and heavy equipment manufacturing, including leadership roles at BWI Group and Suda USA. He specializes in merging engineering, analytics, and operation to drive measurable performance gains. Jayant holds a master's in mechanical engineering from Bradley University, and he has a Six Sigma green belt. He will deliver the keynote on predictive maintenance and process optimization with AI at GSDC Certified Learning Series 2025. We welcome you all. Jayant, would love to hand over the virtual mic to you now. Thank you so much for joining.
Hello everyone. Good afternoon or good morning if it's early enough for you guys. Uh, let me let me show myself. Hi. Hi, I'm Jay. I go by Jay. My name is Jen Dodla. A little bit about the topic we are going to talk about today. So let me get the sharing going. All right. So a little bit about the topic, what we are trying to talk about. So we've over the years we have done maintenance, right? Maintenance of our cars, maintenance of our equipment, maintenance at home for maybe a refrigerator, washing machine, whatever it could be. Over the years, from let's say since Toyota started its TPM processes, Toyota manufacturing TMP manufacturing principles, maintenance has evolved greatly, both in thought process and in technology. So here today we are talking about predictive maintenance, specifically that is optimized with generative AI and AI technologies that are out there. So let's get going. I know, thank you, Pritham. Thank you for introducing me. So again, I wanted to throw in a slide here. So I go by Jay. My name is Jay Dodla. I'm an advanced manufacturing engineering manager at Aztec. What I do here is manufacturing fundamentals, manufacturing principles implementation, launching new products, new innovation, um, new technologies in Industry 4.0, and so on. So right now I'm focusing on manufacturing fundamentals implementation across the company, standardization, and starting the framework to get us into Industry 4.0. So Industry 4.0 now it's coming to an evolution where AI is integrating into it and starting predictive models in various aspects. So that's where I'm focusing on, trying to see how I can get my company from where it is today to be able to adopt AI and use it for various aspects, capacity planning, maintenance, and so on. Today we'll focus on just maintenance, and we can probably come back for a later date for other things. Right. So that being said, so let's look at how maintenance itself plays its role in our day-to-day lives and in the world, right? So let's look at our simple washing machine. A washing machine, you buy it brand new, has zero life on it, and you start using it. It works great for years, probably 5, 10, maybe 15 years. Over time, you start looking at noise, vibrations, and starts draining and leaking, right? Well, how does this happen? That's because not purely because we're not maintaining it, because that's how everything wears out, so, right? But here the problem is we don't know when it's going to fail, we don't know how it's going to fail, and so on. And the best part about this is you can wait it out and let it die, and you can replace it for maybe $500-600, and the replacement and maintenance costs are pretty cheap, right? But what if this happens to your a pump, a PD pump, or an actuator, a linear motor? You don't want it to fail, right? You don't want it to go down and say, all right, in 3 months I've had 1,000 hours of life on it, and it's going to fail. That's not what you want. What it does when it fails is you start looking at downtime. When it fails, where you don't know when it's going to fail, you start looking at downtime associated with part replacement, part not working, and even before it gets to the point of failure, you have these symptoms of vibrations, lack of pressure, lack of right amount of fluid flow, and so on. And you start looking at accommodating these variances across the time, right? So how do we avoid this? How do we avoid this is comes down to three principles: reactive maintenance, preventive maintenance, and predictive maintenance. Reactive maintenance simply means you wait for it to fail, like your household, like a washing machine, refrigerator, oven. You replace it, and life goes back to normal. Preventive maintenance. This one's been adopted for the past however long, right? So 40, 50 plus years. What we've been doing so far is we look at a process or a machine. You look at your OEM manuals from your supplier or your vendor and say, and they probably did durability studies, wear studies, and life estimates on every component that's going into it. And they said, okay, every 30 days I need you to lubricate your bearings. Every 60 days I need you to inspect for maybe a wear in the stator or a gear system or something. So what you see here is it's set in stone, and every so often that you have to perform this maintenance, or else the life won't last as long anymore, right? again, going back to the previous slide, the lack of life is lack of productivity and so on, and it spirals down into a bad business model. Now we have walked into, in the past maybe a few years, 15, 20 years, we've started looking into, okay, how can I get away from preventive maintenance and get into predictive maintenance, right? So the predictive maintenance, we started looking at machine learning. We have started applying machine learning technologies and so on to understand, okay, when will my product potentially fail based on how I've been using it, and not wait for it to fail and not do the preventive maintenance, or let's just time it right, go ahead and fix it or replace it and go back to production, right? So let's talk about what preventive maintenance truly means and how it came out to be. Right, preventive maintenance, again, going back to the TMP principles, it came into being a long time ago. I think 1940s, 1950s around, where people started looking at, why is my machine failing? How can I maintain it better so that I don't have to deal with these day-to-day downtimes or day-to-day or monthly replacements and so on of these components? How can I minimize my cost of maintenance or minimize my cost of production? Right, based on these, they started looking at your durability studies, your capability studies, and said, okay, it looks like every 1,000 hours I need to do this, every 600 hours I need to do this, every 30 hours I need to do this. So that's where preventive maintenance came in from. Again, preventive maintenance, predictive maintenance, everything goes back to doing root cause analysis, right? Root cause analysis gets us here. So what are the benefits of preventive maintenance? It reduces your random failures. You're constantly lubricating, you're constantly maintaining your pressures and so on, so that you are avoiding the risks that come with not doing these activities. So by doing this, you're following your manufacturer's manual, so it protects your warranty, keeps your processes safe, and keeps you humming as long as the machine is capable of humming. Right? These also can be standardized across various machines. For example, my first job was at a CNC shop where we had 6 or 7 different manufacturers for the lack of standardization to a certain extent and so on. But the way we did it was, every machine we have identified over the years, over 50 plus years of patterning it. Okay, every machine comes in, it needs the same basic principles. You need to lubricate every 6 months. You need to check your coolant concentrations every day. You have to check your pressures every start of shift and so on. So this becomes a standard practice across most of your common processes, right? And then this also gives you a predictable wear out timing. So if you do this constantly, you can sometimes predict saying, okay, I'll probably have to replace a bearing here or a LM guide here or a linear guide there. So this preventive maintenance structure gives you predictability, standardization, and protects you from warranty issues with your supplier. But the limitations are cost. You are constantly doing the maintenance, even though probably you don't need to do that maintenance. This is just overdoing it so that you don't have to spend a ton of money in replacing an equipment, replacing your sensors or whatever, right? This is purely because of again, this is risk. This is like an insurance policy. Preventive maintenance became insurance policy the moment predictive maintenance came into vision for people. So simply putting it, preventive maintenance became old school at this point. We are progressing into predictive maintenance. So let's start prediction. What does prediction mean? Prediction is, I'm not talking about reading your arm. We are talking about predicting when a machine is going to fail. How do you go about predicting this, right? Sensing, learning, predicting, prepare, and prove. So you establish sensors around the process, vibration sensors, be it, or pressure sensors, or to a certain extent, even we are looking at temperature sensors that correlate to vibrations and then come out with a predictive model, right? So what you do here is you apply machine learning, where you take a bunch of sensor data, learn from it, learn what your baseline is, learn what what a machine and how it performs. So what is its natural frequency, what is its natural operating temperature, what is its idling temperature, what is its rest temperature. Usually we don't consider rest temperature because of the ambient temperature fluctuations. We look more towards idle and then a full load. Based on that, we establish our baseline. Then we start looking at drifts. How drifts are deviations, right? How is it over time changing, the temperature is changing, your harmonic frequency is changing, or your baseline natural frequency of that machine is changing, and so on. Based on that, you establish, okay, this is how my machine's been performing, this is how my machine's performing today. So based on that, I'll extrapolate a time and date in future where I think based on how it's progressing over time, I might fail. So that's identifying your point of failure and risk. Now you start preparing. Now this is where predictive maintenance stops, right? Machine learning and predictive maintenance stops. We start the moment the machine learning software says, hey, this is when your machine is going to fail, or this component, maybe a sensor or pump is going to fail. We start looking at, okay, the maintenance guy or manufacturing engineer, maintenance engineer starts looking at what is the part that's going to fail. Do I have the parts on hand? Let's go and order it, and so on. So that drives a different thought process, but that's all manual from this point on. By now we are talking about, there you go. So the deliverables of, so we're talking about machine learning and predictive maintenance. Now the deliverables of predictive maintenance, it gives you planned micro stops. Instead of stopping every 30 minutes every day to do your point of checks, you start doing, okay, instead of spending 30 minutes every day, I'll probably spend 30 minutes every 1 month or 1 week to change this solenoid or change this check valve. And that might be cheaper in some instances, right? Fewer surprises, since you're predicting when it's going to fail based on historic data, based on durability studies, based on life studies. You know, or you can predict when it's going to fail, and you say, okay, I'll plan for this date, I'll fix it by this date, so that you're less surprised when less surprised because there are no surprises actually, not when it happens. By doing this, you're reducing the amount of labor, your material spent in maintenance, and so on. Instead of doing multiple maintenance schedules over time, you're doing one specific maintenance of replacing a component at a certain period of time, and that improves your overall availability of the equipment, overall operating rate of the equipment, because you're making more parts, because you have more availability, and so on. Now, limitations, again, prediction. So with every maintenance model, right, we are looking at data sets. What is the data telling us? How clean is this data? Is the data properly tagged, identified, or so on? For example, let's take how machine learning works. Machine learning works based on, you give it, let's take a simple example, right? Dogs versus cats. You give a machine learning software, a model, maybe 1,000 pictures of cats and 1,000 pictures of dogs, and say all these 1,000 are cats and all these 1,000 are dogs. And then you ask the machine to identify what are the differences between a cat and a dog, what are the commonalities between a cat and a dog, and figure out if you can find what is what. And then you give it a test, right? So the key here is the amount of data set you're giving it and the right tags you're giving it. If, for example, within those 1,000, you have 10% data set where one of those cats is incorrectly identified as a dog versus one of those dogs is incorrectly identified as a cat, now your efficiency or accuracy of your machine learning software goes down significantly. So that's why you need clean tags, clean data sets, clean, properly curated data sets. Basic analytical capabilities. Now these are being less and less concerned because of how advanced machine learning has evolved over time using various techniques, right? Now we are talking about CMMS integration. In my company, we are starting to adopt Maintenix. In my previous company, I used Fix, and then previous I used Flex. This is the first time AI has been actually getting into these in the past maybe 2 to 3 years, right? Before this, we did not have any of those machine learning integrations. It was hey, based on PM activity, some level of integration, but not as effective as I want it to be, right? So this is where non-AI prediction rules and thresholds come into play. So non-AI depends purely on single signal. So machine learning can only go in one direction. If you give it too much data sets, too many data sets, like I said, right? Vibration sensor. Let's say again, let's take an example here. Let's say you put a motor down. You're putting in machine learning based predictive model on how when it's going to fail and what's going to fail on it. If you put a vibration sensor, temperature sensor, and you're also collecting your back pressure from your pump, the machine learning is not as capable at analyzing all these data sets. So it breaks down when it comes to multivariate patterns. It's limited to one single data set, either vibration sensor, either temperature sensor, or so on. Now, noise and drift is where when you look at your vibration data set, right? It can find when it's going to fail, but when there is variations because of unknown factors or external factors, not from the pump itself. For example, let's say your pump's right beside a forming press. Depending on what kind of a press or parts you're running on the forming press, the vibrations induced through the contact surface, the common contact surface or the ground, might change, might vary, right? So it's the machine learning process, the machine learning model itself is very limited to identifying these variables and not giving you false alarms and so on. So, and then the keep up itself is pretty high because you're not transferring well into let's say monitoring these data sets. You need somebody over this process constantly monitoring, hey, the quality of data that's going in, is it good or not? Hey, is this a false alarm? Is this the right alarm? Am I getting the right outputs from the system? So this is where you get into the limitations of non-AI based PDM process, PDM as in predictive maintenance. Now let's talk about the next step. So machine learning was the initial step, right? We went from machine learning to large language models to natural language detection systems, and so on. Now we have evolved into AI. Oracle and various other softwares are starting to look at AI agents into their CMMS systems. So how does AI play into PDM? It starts monitoring data real time. You can, similar to machine learning software, you can dump a bunch of data set into it and train it properly so that it knows what it's looking for a specific component, and the data again comes from durability testing from our vendor. It can start looking at, it has a baseline identified. Then from that point on, you start training it using real-time data. Having baseline data from your vendor is different from having real-time data, right? Real-time data, your environment, everything changes where the machine's installed. Now you start looking at, okay, my previous data set told me, let's say, my idling temperature is supposed to run at 35 or 40 degrees C. Now, based on the new environment, it starts looking at, okay, my real-time data shows me over the past 3 weeks or 4 weeks, the baseline shifted, my idle temperature shifted. Okay, is that a problem? I do not know, because again, the data is different. So it will continually monitor a little longer based on your guardrails, saying, hey, don't just continue to monitor and adjust your baselines or adjust your stuff. Here's your guardrails. This is your baseline based on data analysis. So what AI does is it looks at real-time data, old data, establishes a better baseline. From that on, it starts looking for patterns. One-off instance, like I said, when you're running a different part or different process on the forming process that introduces different vibrations through the system, it might say, okay, this is a one-off, I'm not going to give a false alarm. This is a one-off, I'm not going to do that. But if these one-offs constantly repeat every 6 days, 4 days, 3 days, 1 month, or so on, that leads to a pattern, right? Every time it sees a spike. And if the spike's growing, or if the spike is happening at the same time, same day, every day, and so on, it finds these patterns. Based on these patterns, it can now integrate into the CMMS. So one good example is Sensei from Siemens, where we'll talk about it later down in the presentation. So it integrates into the CMMS and says, okay, looks like this component for this part number on this asset is potentially going to fail on this date. So let's order something, right? Let's order this component that's going to fail. Now, since it's integrated into the CMMS system now has a complete visibility. Let's for ease of communication, let's say instead of CMMS, seems like a tongue twister for me. Let's say maintenance, right? Maintenance has an AI agent. So the AI agent now says this component is going to fail because of these patterns I've seen so far. That means on, let's say today is October 14th, on November 15th, I need to replace it, potentially replace it. So do I have the part I need to replace? Where is the part located? If your company is a global site, can I expedite that part from elsewhere, or can I get that part internally transferred? Do I have to place an order if there's no stock in everywhere? So it starts looking at, okay, oh, I did jump a little bit. So it starts looking at putting in work orders by itself, which again, guardrails, right? You have to approve, somebody has to approve the work order, making sure it got the right data set in there to a certain extent. And then you start looking at where your parts are. If you don't have a part, issue a PO. So the AI agent is now automating all of this instead of having the PM and the machine fail. Do a PM, but still the machine fail. Once the machine fails, we scramble to find the maintenance guy who's capable of replacing this. He goes, investigates, identifies that, hey, this component did fail. I need to replace it. He then goes to the accounting firm and says, or the purchasing firm and says, I need to place this order. I don't have stock. Go place this order, and so on. All of this can be eliminated with AI integration into your CMMS system like Mainnex or Fix or whatever, right? How does this future look like? What does it mean when we talk about AI predictive maintenance? So the idea, again, going back, is fewer micro stops. Instead of stopping every day for 30, 45 minutes, you're stopping less. You're stopping less every day, maybe instead of stopping for 30 minutes a day, you're stopping for maybe an hour every month or so on. So that's 30 minutes back into your production time. Predict, schedule, and kit parts, right? What does that mean? You're predicting what's going to fail. You're scheduling your work orders. You're scheduling your when your maintenance guy arrives. You're scheduling if you don't have the parts, when the parts arrive, and then you're kitting the parts and ready to go. You're not waiting for everything is done parallelly while your production is still running. You're not doing this when the machine's down. So what does that translate into, right? Your OEE goes up, your mean time to repair goes down, or mean time to response goes down, your mean time before failure goes up significantly, which are all the right indicators that your business wants to see. So all of this can be achieved only at some point. Let's say we've been doing it, but better, right? More in a better way by having CMMS integrate AI into it. So AI agents have to be a part of it so that you can make this into a closed loop system instead of with less and less human interference or human interface. So now we are talking about, let's say you do all of this. What does that mean for people that have been for teams, departments, and companies that have been used to doing PMs, machine breaking, replacing it, and so on? How does that flow into all the departments that are touched by this process with AI and CMMS systems, right? Manufacturing engineering. Let's talk manufacturing engineering. Sure, I'm guessing, I'm assuming most of our in this webinar are all manufacturing engineers. That's where I started, right? Now we are looking at DFM. When we manufacture our machines, let's say I'm the customer for most of the machine manufacturers, right? So I'm expecting my manufacturing engineering department at my customers to start looking at design for maintainability into DFM. How do I maintain it? For example, I'm sure you've seen some Instagram memes where your oil filter in German cars is hidden so badly that mechanics complain. I don't want my mechanic to complain when I'm designing my machine. He needs to go, man, this guy's great. He knew how to get to this, and he made my life a lot easier, like Toyota does, right? Digital twins and FMEA insights. So the FMEA data sets feedback into the AI system, saying, hey, this is how your component's going to behave and so on, or what your failure modes are, what your effectiveness are. So we bake that into FMEA system, PFMEA and DFMEA. So as we build these machines for AI to actually work, you need to have some level of sensors, right? Some level of data input. How do you get your data? Your data comes from your sensors like vibration sensor, temperature sensor. So you need to make that a part of your spec when you're specing your equipment, your process, and so on. Cost of failure considering gate reviews. So the cost of failure is a very advanced term for most companies out there. Many companies do not. When we spec a machine, when we are going through a project review, I've seen in my past experiences, most companies skip over this or don't even consider this as a possibility for bad business model, right? For example, you might buy a CMS machine that's a clocking machine that aligns your valves and damper system, valve discs and damper system. Now, if it fails, what is the cost? That's something we never baked into our process. And then when we later on looked at our process and why am I spending so much money in making something? Why is my business case different from my real-time business case? We started looking, we did a root cause analysis and found, oh crap, we did not look at this in the form of what happens if the machine goes down, how, and so on. So those cost of failures should be considered gate reviews, help manufacturing engineering be more prepared for this AI-based PDM systems. For operations, now you're looking at reduced micro stops, so increased OI, so better shift planning, better flow of process, and so on. And now that translates into your KPI of improved OEE, MTTR, MTBF, like we discussed, right? Maintenance, for maintenance, this is going to be the biggest hit. Maintenance will have to start adopting from break fix, as in, let me fix it if it breaks, to condition-led work, like, okay, it looks like the data is telling me it's going to break at future state. Let me get everything ready so that I replace it before it breaks. And they are better planning for it. So for example, that drives down to kitting, that drives down to signaling and symptoms validation, that drives down to work orders issued by CMMS, and feedback loop saying, hey, I closed the work order, this is what I found, this is what I replaced, and the CMMS now learns if there's anything new that it did not predict and starts looking at, okay, it was not the bearing that went, I thought it was the bearing, it's actually the shaft that's wearing out inside the bearing, it shouldn't happen, so on. So there's probably something else in there that's causing the problem. Now the challenges, right? AI, we make it a glorified, an intelligent being at this point. I mean, I'm sure we're all using ChatGPT. I mean, some of these pictures I've created is using ChatGPT, right? We're all using ChatGPT. We are asking it to streamline our thought processes. We are asking it to draft better emails to our colleagues or to our superiors or our reportees and so on. But what are the challenges? I mean, what causes us to less adopt this AI-based PDM system? The most and important one is cost. For example, for ChatGPT, they're charging you $20 a month for subscription. Gork is charging you $30 a month. Copilot, you have to pay another $22 a month, I think, with taxes. And then if you buy the Microsoft 365 package without Copilot, is $139 a year, and with Copilot is $199 a year. Again, simply putting it, the key term is cost, bucks, right? So high initial investment. Mainnext, Fix, Oracle, and all of these guys, they are saying, hey, I'll give you AI, but you have to pay it. So how do you justify that cost? That becomes a big challenge for the new and upcoming companies, because we have been doing PMs. Now we are shifting our thought process, culture, and practices into PDM system. That makes it harder for business entities and manufacturing engineers to actually get a proper ROI without knowing what it's going to do prior, right? Data quality and integration, like I said, we spoke about before. we spoke about tagging the sensors, right data sets, right training data sets, and so on. If any of these data sets is not right, you will fight initially, significantly actually. There is actually a case study out there that led to this thought process. You can click on the link down below, or just copy paste it if you're looking at it, or type it down. So this group did a really good case study on what happens, what are the costs associated with, and the challenges associated with predictive AI in PDM systems. So data quality is key, and integration of the data itself is key, as in putting your data sets in the right place, right time, and tagging the system to look at the right data, right? Skills gap. This is where we are actually struggling right now. AI-based thought process, AI-based thought process, AI-based our skills to actually use AI right, or program AI and maintain the softwares is highly sought after, and it's getting extremely expensive to find somebody. Again, hitting back on my experiences, if I want to hire an Oracle engineer who's not worried about AI, it's pretty cheap. It's not cheap, but cheap compared to somebody who knows how AI works, who has experience, who has the skill set to deal with AI-based background coding, background maintenance, and so on. So that's causing a big challenge in this future adoption. Organizational resistance. Now we are talking about all three of this group together, right? For example, imagine yourself, you're going to your manager, your vice president or president, and saying, hey, there's new buzzword going around that's called AI agents and maintenance. I want to move us from preventive maintenance to predictive maintenance using AI, and you show them all these wonderful things it can do, right? Predicting and work ordering, scheduling, and so on. But how do you justify it? Without justification, nobody's going to give you a blank check or a check to say, yep, go spend it, right? Everybody's looking at, if I'm spending $1 billion on this process, on the software, what's my ROI? Can I get it back in less than 3 years, or can I get it back in less than 4 years? How do you get that? And thought process of going from preventive maintenance, which is an insurance policy, to predictive maintenance, saying, I will predict when it fails and then change it. Now that becomes rather than a set in stone that I'm doing this activity, it becomes I'll do it when it happens, or just before it happens. Is a scary thought for people for organizations who are trying to spend money to adopt to that cultural shift. ROI justification, we spoke about it. So the complexity and scalability becomes the second most important topic. Putting this on one equipment or one machine is fairly easy. It's simple. You're looking at a small set of data sets. So the processing power, the servers, the infrastructure you need is pretty small. But now start looking at a global company like Aztec, where we have 8+ sites in North America, a couple sites in India, a couple sites in Ireland, in Brazil, in South Africa. Now we are looking at scalability, right? What I do in one site, everybody will start calling me and say, hey, Jay, can you do this for me? Can you do this for me? Can you do this for me? But before I can do that for everybody, I need to start looking at the servers I need, the infrastructure I need, the complexity behind setting up all these systems, making sure I have clean data from every site, and setting up the resources to maintain this clean data set. This becomes a big challenge when it comes to implementation stage. Cybersecurity is a big concern right now. For example, I was in a meeting a couple of weeks ago with our AI core team, AI-based core team, where we were talking about, okay, everybody is using their own flavor of AI, like Gort or like ChatGPT, like Microsoft Copilot. How do we keep it? How do we protect our company's data? How do we make sure that somebody's not just taking this data set and posting it in ChatGPT, and not for bad intentions, but to get a better answer, better root cause, or so on. I mean, you don't want to put a drawing in ChatGPT in your personal ChatGPT. they say it's safe, but nobody knows how safe it is. I mean, I'm a pessimist when it comes to data set, when it comes to putting anything in AI. The funny part is I am actually very conservative when it comes to AI adoption, because especially in my company right now and how we are laid out, because of how it's still in the evolution state. I think there's more to happen in the cybersecurity world, in the data privacy world, before every company starts looking at, okay, my data is safe. I can start adopting AI now, or somebody has to prove me that my data is safe, right? All of these, again, have been well studied in maybe a few, but some case studies. And one of this one that I've posted down there, if somebody wants to take a screenshot, is a great study. Go ahead and do it. It will give you some really good insights. So now coming into the case studies, right? We spoke about maintenance. We spoke about Oracle-based AI systems. We've spoken about FIX AI agents. Siemens, on the other hand, is something we didn't speak much about. Siemens, we all know Siemens in their VFDs, in their PLC systems, in their Siemens factory floor, Siemens Live, and so on. Siemens has started their software AI-based fixed system integration called Sensei. The way this system works is no different from how I've explained in the previous slides of how it integrates into your CMMS, data collection, prediction, ordering, and issuing work orders, and so on, or resource allocation, and so on. So there is a case study on Siemens itself that talks about how they deployed AI in PDMs across multiple automotive manufacturers, automotive industries, tier 1, tier 2 suppliers specifically, and how they integrated into machines. So every single site seemed to have saved. Now they're talking about just percentages and round numbers. That 50% downtime reduction. When they say downtime, they're talking about not just downtime caused because of failure, but downtime for planned PMs. All of these combined together, saving 45 million in less than 1 year, or up to an average of 1 year, is extremely great. I mean, that's people, when you present an ROI to your senior management, they want to see a typical ROI less than 2 years. Having a 60-day to 90-day ROI is absolutely mind-boggling. So I'm hoping most of us can start looking at AI adoption again with some level of guardrails into data protection and data privacy. So talking about the second set, where again Siemens seems to be doing a great job in AI adoption for our maintenance systems. They've implemented the system in Australian steel facilities across New Zealand and so on, where they were able to reduce the downtime, again, planned and unplanned downtime, significantly, giving a better OE, better MTTR, MTBF. The problem in this case study, I think the data set was not allowed to release. They did not provide anything on the how much dollars they've saved, but seems like the amount of hours they've saved is extremely great. 2,000 hours unplanned downtime avoided over 3 years. That's significant. Imagine a process that makes a damper from where I previously came from every 4.5 seconds. How many can you make in 2,000 hours? That's mind-boggling for me. Right, that's more production time, less standard labor costs, and so on. So this is where this is another case study I picked up while I was doing research on how AI is being integrated. So C3 AI Reliability is another platform that predicts failure modes and so on, and controls how many false alarms you're getting. That ties into an AI system. So again, I've linked all of these case studies in my presentations. We can go about looking at it, or you guys can take a screenshot and go hunt them down. Great case study, great research papers, great white papers. Now I want to take a pause here on this presentation and talk about the limitations of these case studies, right? All of these case studies are talking about how the companies are benefiting from AI, but let's look at how many case studies are available on the market right now. Me spending almost, even before I was approached by GSDC to give a webinar on this, I've been researching AI for a long time, trying to see how I can, like I said at the very beginning, implement this at Aztec at my company. How do I get the company on board? How do I integrate it? What do I need right now? What are the gaps that's stopping me from today in the next 5 years to get my company where I want it to be, what my vision is, and so on. I've faced the same exact challenges presented here. Company adoption, company justifying an ROI, and so on. So while doing this, the case studies I've found are only a handful. That tells me we are very, very early. We're pretty much in the infancy state of adoption for AI systems. We might be growing pretty quickly here, starting maybe 2026, because of how many mainstream CMMS systems have started adopting AI, but it won't be an exponential growth, right? The exponential growth of adoption comes when the cost is significantly lower. But again, it's a catch-22, where the cost is limiting the adoption versus the adoption is limited by the cost. So there's probably at some point where people will, or companies will, realize what AI can do for them and start adopting it more and more. Here are some references again: Prometheus Group, Siemens case study, C3, and Department of US is doing a great study on operational efficiency, and they've talked about a lot of AI integration into their own systems and own facilities, and how they're providing grants and support for companies that are willing to move in that direction in the near future. All right, that's me talking so far. Do you have any questions? Please go ahead, and I'm willing to answer.
Hi, Jayant. Thank you very much for amazing session. So, do you want me to read the question? Because I can see that we have got some question in the chat box.
Yes, actually. Yes, I see some questions there. Is that from Shimul S? I see three questions actually. Shimul, Mahesh Krishnan. So Shimul, your question is: are there guidelines to integrate AI toolkits with traditional risk management models like FEA during design stage at FMEA, CAPA? So at the FEA stage that's a good question. I've actually not looked at FEA stage, but yes, there are tools that are being developed to integrate into FEA model analysis and so on. But so far, it's not well adopted, even at big threes in the United States, like the GM, Ford, and so on. They're still on the fence of adopting it. To my knowledge, BMW and Mercedes have started looking at adopting this. And also, I don't know if you know Mercury. It's a I'm a car enthusiast, so Mercury is a one-off company that makes $1 million cars. They are adopting AI into their design phase for FE analysis and so on. Case study 3, takeaways: cutting false positives. Yep. Obviously, the whole science of statistics for data metrics goes into false positive. Shimo, can you explain? Sorry, I'm not understanding this. Is that not an obvious conclusion? Yeah. So actually, yes, it is. It is a basic conclusion saying, all right, if you do not have, if AI is also giving you false positives, what's the benefit, right? Yes, exactly why I said AI should not only depend on historical data that you're providing it from the owner's manual, from the supplier, but also has to learn and should learn from your operational environment. If not, yes, your false positives and everything comes into play, and AI itself becomes useless. Mahesh, how could AI control OE, MTTR, MTBF by predictive analysis? So you're not directly influencing OE, MTTR, MTBF, or OE specifically, but it's a derivative of how AI predicts when your machine is going to fail, improve your downtime, as in instead of doing let's take an example, right? A pump goes down, you need to replace it. Now the downtime to replace it when you're not ready for it is significant. You don't have resources on hand that can go and fix the machine or replace the pump. You probably don't have the pump that you did not think will fail on hand, so now you have to expedite it and so on. So that's how your OEE is affected. Now, because you're not ready or not ready to respond and repair it, obviously your MTTR has skyrocketed. MTBF, on the other hand, mean time before failure, you instead of letting the pump fail, let's say you're predicting when the bearing goes out, when maybe a shaft or stator goes out and so on, and you have parts on hand, you replace it, you fix it, you get it back. You're actually not you're not fixing it, you're doing maintenance on it again and getting it back on process. So it's not typical failure. You're not letting the process fail or a machine fail. So that's how AI can help improve your OE, help reduce your MTTR, and increase your MTBF. The best practice for data, good question. So let's see. So far, to improve your data sets that goes into an AI, what we have implied is a regression analysis of how the data is being presented, right? Or what kind of data is being presented. We have to set up some level of cleanup methodologies to remove any outliers. When actually, good point here. When you're feeding data into AI models, AI systems, you really want to establish your true baseline. So you need to eliminate these false outliers or so on, and see if you can find a true baseline in your data set first. That's where one of the key best practices come into play. When you're putting in data sets, you really need to control to make sure you do not have these spikes presented in it. When you present the spikes into an AI system, the way it normalizes the baseline, it probably raises this baseline or drops the baseline depending on your environment and your environment, usage case, and everything, and says your baseline might be lower than what it is, and everything becomes a false positive until it actually learns again and gets back to a proper state and says, oh crap, I was fed with wrong data, right? So yeah, you have to make sure your data sets are clean. You don't have these spikes in there. You don't have this outliers in there, and you have to spend some time on training. There's no other way around it. What are the core aspects and parameters or metrics to be considered in FMEA insight models? Is there any framework for this? Good question. Honestly, I do not have a good answer for that right now. That is something I haven't dug in much deep into. I'm still in the process of evaluating how and what AI to be adopted, and where does the market lead to. The show, depending on industry type. Yes, actually they are. Again, to my previous comments, right? Oracle is coming out with an AI system. It's supposed to be released with its Redwood interface. I think it's ready for 2026 right now. Mainnex, we are trialing Mainnex AI agent right now. That's suited for heavy equipment manufacturing. FIX is working on their own AI that does not have to be a custom build off shelf. Pick it up, you can run with it. Oh, good question. So not really. There is no specific course. There are it's that set of courses offered and everything is actually evolving because it's new adoption right now. I would say I don't know, man. I'm really don't have a good answer for what course that's good for manufacturing specialists. I would say just Google it at this point. We are still evolving, so there might be some available, but I don't trust them yet. I want everybody to adopt AI in a full extent, learn how it's working, and then start offering courses instead of saying, hey, here's your off-the-shelf AI-specific course for manufacturing and so on. All right. Anything else? All right. Different parameter types, and this is, yes, I've worked all of them, including big ones in RMS, particularly. Yeah, exactly. Yeah, that's a good point. Data formats is a big key. Having different data formats within a global organization like Aztec, right? In US, we use month, date, year, and then when it comes to India, it's month and dates are switched. So yeah, it becomes a challenge. But again, remember, right? If AI is properly integrated into your CMMS and has been properly trained, depending on your geolocation on which site it's looking at, AI should be capable of deciphering, hey, I'm looking at Indian subcontinent, so I should not see the first two digits or first two letters numbers as months but dates. So I'm expecting AI to be that smart. Hopefully, if not, we're in big trouble. Engineer for AI specialist to manufacture if he is able to understand manufacturing problem. Is it necessary to be an engineer for AI specialist? For AI specialist for manufacturing. If I understand that question right, so Mahesh, I don't think you have to be a specialist. I'm not a specialist. I've done no courses in AI. I'm probably, the sample size is pretty damn low here when I say I. But my department, let's say my department right now is growing. We are about 20 people, but specifically process related are 3. No, they did no AI-based training, no AI specific courses, nothing. We are learning on the go. Like I said, the entire manufacturing industry is always a little behind when it comes to adoption of new technologies, processes, features that the software industry offers. So no, there's no need for a specialist, and that's a key for AI, right? If you have too many specialists in there, what's the point of having an AI that's supposed to clean up your day-to-day activity? How do we ensure AI accuracy? Again, that the AI accuracy in simple and dumb terms goes back to the kind of data sets that's fed into the system. If your training data is bad, your predictive analysis is going to be bad, right? Trash in, trash out. This is a very good system where it truly depends on what kind of food you're giving it. You don't want to give it junk food. Any quality standards followed while developing the AI-based systems? Good question. I think that's also an evolving system right now. Again, like I said, I'm part of the AI Council for my company at the highest point. So we are still trying to figure out what are those guardrails we need to put in, what kind of standards we need to put in so that AI is operating within this box, or let's say not really a box, but within this standards, so that we are getting good data sets out, limiting our cybersecurity risk, limiting our data privacy risk, and so on.
Then, meanwhile, can we take one question that we got across live?
Yeah, sure.
Yeah, so there's a question asked by Kuldeep. Which AI models or techniques have you found most effective for predicting equipment failures?
Good question. I've researched a few, but what I've landed on, again, so the data available, again, going back to the case studies and the comment I made at the end of the case study 3, every data set model out there has been performing equally similar. There is not one specific model right now that's outshining. Everybody's adopting different sets, but again, it's not outshining. And at the same time, the amount of data or studies or research or meta-analysis available out there is very limited to say this is better over the other. We need a little bit more time out there before we can say this is a better data model or data set model available.
Wonderful. Thank you so much, Jayant. Yes.
The data governance initiative covering DQ to have been a failure globally in most of our trying to establish. True. Exactly true. Yep. How well you made sure to validate the 6 core principles of AI manufacturing in case of organization is using AI and to be compiled with law of land and regulators. Again, so like I said, every company is facing the same problem like we are right now, where the individuals of the company are using their own flavor of AI like Bark and so on. These guardrails in manufacturing especially are still being built upon. Initially, there was a rule passed in some companies and where my colleagues worked, where ChatGPT usage of ChatGPT alone was frowned upon, but now it's 180-degree turn. Everybody wants to start using ChatGPT so that you get faster results, maybe not better, but faster results. Instead of taking 24 hours for a root cause analysis, you can get a root cause analysis in under an hour, the moment from the time the issue was identified. So we are evolving. There are not enough guide rails and regulators available or identified yet. That's still there's still to be some level of learning to be done on that. How is it possible to predict maintenance? Again, so going back to my presentation, right? We can predict maintenance simply by understanding what the data is telling us, what the vibration sensor is telling us, what the temperature sensor is telling us, and so on. If you see an outlier and that outlier becomes a pattern, that's when you see, okay, this is actually degrading in life, and you extrapolate a time in the future and say, okay, this is when I need to do a maintenance on an equipment and so on. AI facilitate market feasibility study, more specifically especially good question. Really good question. That's going to be a little bit of a. So let's imagine assume the environment in rural areas, right? You're going to struggle with basic infrastructure that an AI needs to function properly. A good network access, a speedy network access in reality. A good network access is not going to cut the chase, right? So most of the feasibility studies, market feasibility study, most specific. Yeah, that's a tough one. I'm sorry. Especially in rural areas. How are we doing it? Most of our equipment is out in the rural areas, and we are doing AI-based studies on our equipment. Again, it falls down to infrastructure. The only thing I can imagine based on my research, leads to is there's not much people are doing in rural areas, especially we are doing something with our equipment newly using what we call mines, where we are collecting data, but most of that is spotty if, again, supporting structures around it are not available properly. So yeah, I don't think there's much being done on that yet.
Then there's another question across live asked by Victor. Which AI models or techniques have you found most effective for predicting equipment failures?
Sorry, so this seems to be a repeat question. Again, sorry about that. Right now, again, every company is identifying their own flavor of AI model, and they're running with it. Right now, in the mainstream, there are probably 4 companies, again, Oracle, Mainnext, Siemens, Fix, that are adopted this AI systems. Not enough data to say this is what's effective, not enough research papers, not enough data analysis, not enough meta-analysis to say this is the most updated, most reliable model out there.
Okay, there's another question. How
Mhm.
can smaller manufacturing units adapt predictive maintenance without extensive AI infrastructure?
So the dumber version of AI infrastructure is machine learning. There are softwares out there. I haven't used one extensively. We have coming from a preventive maintenance company. We've dabbled in the thought process of getting machine learning based AI, machine learning based predictive maintenance in. So yeah, if you don't want to go full version of predictive maintenance using AI, you can go down to machine learning based softwares that are again available. I think if I remember right, it's been a few years now. FIIX, and there was one other company that offered this capability, but it was at a significant cost. We didn't want to go ahead with.
Wonderful. That's it from the live platform. I request all the participants, please drop your question if you have any. We still have a 5 minutes we can cover for Q&A. So drop your questions. Okay, I'm sharing Ajay's LinkedIn profile link in the chat box, so you can reach out to him. I think this question is for me. Will the slides be shared so we can have access to the references link?
Sure, I can share this slide. How do you want me to do that, Pritam? Can I drop it in
So
here?
once we get slides from the Jayant, we'll check it with the team and we'll get it done.
All right, sounds good.
All right, here we'll be stopping with the Q&A. I don't think so more questions coming up. So in case if you have any further questions for Jayant, please feel free to reach out to him, or you can tag GSDC. One of our SME will get back to you with the answers. Thank you everyone for engaging session. Thank you so much, Jayant, for being here. It is amazing session, of course, and we'll be definitely reaching out to you again, as we would love to have you as a speaker for future events as well. Thank you so much for your time. So before I proceed further, would like to hear final thoughts from you for all our participants today.
Oh, sorry. So again, I'm a pessimist. So whatever flavor of AI, staying on the same topic, AI predictive maintenance and so on, you're trying to look at, be thorough with it. Look at don't just look at what it can do to your predictive maintenance and capabilities, but also look at what it does to your data, what it does to your IQ within the company. There is a study out there that says people who have been using AI extensively for their day-to-day tasks, for most of root cause analysis and so on in manufacturing, has had a drop in overall IQ at every firm. So I would say, please be careful with what you're using AI for. Don't use it to make your life easier in the form of root cause analysis where you need to apply your skill sets. But we use it where it's non-value added, like predicting, like maybe finding these patterns in data sets and so on, that we don't have to sit down at a desk, look at screens, look at these data sets. So be careful with AI. AI is a great tool, but also at the same time, a tool that can make us extremely lazy as engineers. So be careful with it. Thank you very much.
Wonderful. Thank you so much for sharing your very wonderful thoughts with us, Jan. Thank you so much for a session, amazing session again. So yes, as moving forward to the session, I would love to inform all the participants that we do have some announcement. So you must be aware that this is regarding the certification on today's feature session that we had on certified generative AI in manufacturing. You can opt out for this certification. You can use this promo code, which is AIMF25, which means you will be getting 20% discount on this certification, and this is only valid for certain period of time. Do grab this opportunity. I have already shared all the offer details along with the link and the promo code in the chat box. This certification, whatever the certification you get from the GSDC, that comes with lifetime validation, which gives you learning resources where you'll be getting a lot of case studies, e-learnings, book of knowledge. Also, the certification are lifelong learnings, which gives you learning flexibility, and you'll be having a lot of opportunity to connect with our partner channels, and you'll be having opportunity to work on the capstone project. That is something real-time AI simulation practice. So do grab this opportunity and do sign up yourself self for this amazing certification. You can reach out to our learning advisor in order to they will assist you further. Also, you can check our website, that is www.gsdcouncil.org, to get more information or details regarding this certification. Also, this is utility tool. This tool is very amazing. It will help you to improve your LinkedIn profile score, your AI skill score. Also, it will help you to build your personal brand. Also, it will help you to create AI generated resumes. So check this out. You can use this August 100 as a promo code to get 100% off, which means absolutely free. And this is only for our webinar attendees. I've already shared the utility link in the chat box. You can check it out, or I can also share it after this announcement. Let me make this announcement. Tomorrow we'll be having another session of this webinar series with Sridhar Ratagonda, and he'll be taking us through the topic that is drive smart production and operational efficiency with AI solutions. So please do join us on 15th October 2025, that is tomorrow, with the same time slot, that is 8:30 a.m. Central and 9:30 p.m. Singapore time. We're running this AI tool challenge, another series which is started from 18 August onwards, with a time slot that is 10:30 a.m. Central, 11:30 p.m. Singapore time. We're having the same time as of now. If there's any changes in the time, we'll definitely let you know. We had this amazing panel of speaker AI expert earlier. We already had 33 sessions, and it is again started, and we are planning to do more. The challenge is extended till 100 days. So please do join us for the remaining challenges, as each speaker giving us a live demo on AI tools with practical walkthrough. So don't miss, join these sessions as well. This session is happening exact after 45 minutes. You can join us. Thank you. So this is regarding the winners. Let's congratulate to them. They have referred maximum people to our session. So if you want to check where to check the points on the leaderboard, just I would love to quickly show you all where you can check all the points that you have earned so far. Just give me a minute. I'm sharing my screen. I hope my screen is visible to you all. So here is the it's very simple. You just have to go to our website and just access our event web page, where our event, the ongoing event is happening, right? So this is the event web page, and you just have to scroll down a little bit. Here's the leaderboard legends, where you can see we do have these three winners who have ranked first at our leaderboard by referring maximum people, and this much points they have earned. So you just have to put your name here and check how many points that you have earned by referring people. So for that, you have to refer the people, and of course, referring people people is something that you are taking a step ahead and taking a step ahead and becoming a thoughtful leader, because you are referring to people very powerful on the and knowledgeable sessions like this. So refer maximum people, as we'll be announcing all the winners at the end of this webinar series, which is Friday. You still have a time to be our winner, because the winner will be getting rewards that is worth $400. Isn't it amazing? So do grab this opportunity and do refer maximum people to our session. Coming back to the main slide, of course, the winners will feature on the GSDC Wall of Fame, as you can see, as I showed you all on the leaderboard, right? So yes, and also if you want to be speaker for our upcoming events as a featured global speaker, you can definitely reach out to us, as we'll be having global platform for you, that is learning capsule, webinar, and the podcast. Please connect with us over the LinkedIn, scan this QR, connect with us over the LinkedIn, check our website to get more information, to check all the offerings that GSTC has for all of you. Connect with us over the WhatsApp group to get daily update on events, webinar, boot camps that we do often conduct. And please do share your valuable feedback on the Trust Pilot. I've already shared the link in the chat box. Please do share your feedbacks. And thank you so much for joining today's session. I hope to see you all for the upcoming sessions as well. Until then, thank you very much. Until then, take care and keep learning. Thank you very much, Jayant, for joining us. Bye, everyone.